Hello students, good evening to all of you all. Assalamu alaikum. Welcome to the online session. Can you all hear me clearly and see the screen clearly? Am I audible to you all?
Yes, sir.
Okay. Yeah. So let's go to the discussion. I think some schools they have started the exam, so yeah, those students can watch the recording. If you all are having exams tomorrow, you all can leave the session and study for the tomorrow's exam and later watch this in YouTube. If you're having science exam tomorrow, then I think this is better for you all to stay and watch the session. But if it is some other subject, you all can study for it and just later watch this recording in YouTube. Okay, so last week we were discussing about the series addition pattern of resistors and parallel addition. And related to series, we did all the questions also. Parallel related questions. Addition part, okay. Parallel addition also we did. Only thing is parallel current related questions we did not do. V equals IR questions. No, not the A level. Some international schools are having exams these days. So those students you all can, yeah. Then before going to that parallel current question, if you take a resistor, already in the theory classes we discussed this part, but some students were having a doubt because there are a lot of papers related to length, area and temperature related to resistor. Not only the normal addition and series addition, parallel addition, they used to ask questions related to the change of resistance with length, area and temperature. So if you look at it, it's like this. Factors affecting the resistance of a wire, any wire or any metal conductor, a metal which can conduct electricity. If you look at that, there are actually 4 factors which affect the resistance of a wire. 3 are internal. So you can say internal factors and external factor. 3 internal factors and 1 external factor. Yeah, first internal factor is the length of the wire. Length of wire. So if you consider the length of the wire, if the wire's length is shorter and let's say there are 2 wires, this is having L1 length and this is L2. Obviously L2 is greater. Length is greater. Remember, length and the resistance has a directly proportional relationship. That means when the length of the wire increases, resistance increases. So longer wires have more resistance because current has to travel a long pathway, in the longer wire. So barrier is more. Shorter wire, quickly it can travel small distance, but longer wire, longer distance, therefore we consider the resistance to be higher. So if you consider this L1 and L2, the length of L2 is greater than length of L1. Therefore, resistance of R2, if you think the L1, L2 resistor, this is 1 and this is 2. The second wire, same material, same thickness, only change in the length. R2 resistance is greater than R1. That is because of this thing. Length and resistance is directly proportional. Hope you all are clear about it. Then the second one is area of cross section. So in other words, you can say thickness of the wire. Area of cross section or thickness of the wire. So if you take two wires, same length, but one wire is thick. Let's say this is X wire and this is Y. Y is thin, X is thick. So I can say that the area of X is greater, area of Y is lesser. Area of X is greater, area of Y is lesser. The relationship between area and resistance is inversely proportional. When area increase, resistance decrease. When area decrease, resistance increase. Yeah, this is grade 10 current electricity chapter. They are coming under internal factors. First internal factor is length. Second internal factor is area of cross section. So here, resistance of X will be lesser than resistance of Y. Because Buddha, it's like this. If you take a road, if the length of the road, not the length, if the area of the road is greater compared to a narrow road, more cars can travel. For example, if you take this, let's say about 3 cars can travel in this road, but only 1 car can travel in this narrow road. So broader road, less barrier, narrow road, thin road, more barrier. Actually, barrier is only resistance. So we can say when the area increases, barrier reduces. That means resistance reduces. More current can travel. When the barrier reduces, more current can travel. When the barrier increases, less current can travel. So in these two internal factors, depending on the increment and decrement, you can get a rough idea of the resistance. Now, for example, if I want, now I'll write the external part in another one. If I want to get a high resistance, okay, to get a very high resistance, what type of a wire should I use? Comparing these two factors only. I have to get high resistance. What about the lengthwise? Long wire, area wise, thin wire. Long thin wire will have more resistance. So if I want to get low resistance, very low resistance, that is good to conduct more current, I should have short, thick wires. The resistance will reduce. I hope you all are clear about it. Okay. So let's keep it like this. From this, we can directly decide. No? Then the next factor, internal factor, is material. Material of the wire. Different metals have different resistance. So, according to general electricity and according to our syllabus, silver is having a low resistance. Copper is having a low resistance. Other metals we don't know, they have not given a proper clear value. But these two we should know. Silver and copper are low resistance. Nichrome and tungsten are high resistance. Nichrome and tungsten. I'll write it here. So in our syllabus, the highest resistance two metals are nichrome and tungsten. So any heating coil, anything which has to have high resistance, anything which has to have high resistance, it will be made out of nichrome and tungsten. Something where you have to conduct electricity properly without any barriers, less resistance, silver and copper can be used. Silver is expensive, therefore in the home wiring, they use copper. So are you clear about the three internal factors? I hope you all are clear about it. Any doubts you all can ask. Which one will get heated fast? High resistance or low resistance? High resistance, quickly getting heated. Okay, can you take a screenshot? Let's go to the next one. Is tungsten considered the strongest metal? No, no, the tungsten is very, like, if you take thin tungsten, it is like hair. So, please take a screenshot of this if you all have not written now. If you all don't have the notes, just take a screenshot. You'll go to the next one. Yeah, carbon fiber, when it is reinforced, it can mix with other material and made it into sheets. Yes, it is strong, but we can't say it is the strongest. If you're considering all the material for now, osmium, diamond, those ones are like very strong. Okay, the external factor is temperature. Internal factors we had three: length, area, and material of the wire. Now let's go to the external one, that is temperature. If you look at temperature, and resistance of wire. Here we are going to talk about conductors, normal conductors. Grade 11, you will study two special conductors which are known as semiconductors, germanium and silicon. Their concept is totally different. Okay, don't worry, that you all will learn in grade 11 electronics. For now, germanium, silicon are semiconductors. They follow a different pattern. But all the other metals are conductors, normal conductors. Normal conductors, what happens to the resistance with temperature? Actually, when temperature increases, resistance value also increases. Why is that? If you take a metal, let's say this is metal, there are metal atoms, and the ones which conduct the current is the electron. So the electrons are traveling like this. But why the electron travels, all that we have discussed in our theory classes. Initially, when the temperature is not high, these atoms will be just stable in one place and the electrons can travel through the gaps. But when the temperature increases, okay, we call it as mean kinetic energy increases. Mean kinetic energy increases, therefore, atoms start to vibrate. That is what happens when the temperature increases inside the metal. These atoms will start to vibrate up and down. Then when the electron is going, there are many atoms vibrating up and down. So it's very hard for the electrons to pass. More barriers are created. That is the concept of temperature and resistance.
Okay.
It's like, let's say you're driving a car, people are just standing in the road, in the middle of the road. But they are just standing in one place. They are not moving here and there. You can drive the car like this and escape and go. But what if they are moving here and there, just crossing up and down the road? Then you can't drive the car, no? You have to stop the car, wait for them to cross or wait for them to move, and then you have to go. And like that, the electrons, when the temperature is increased, when the atoms are vibrating, they are unable to pass through. So it delays the travel of electron, which means barriers are increasing, resistance is increasing, current value will reduce. So final conclusion, when temperature increases, resistance increase. When temperature decrease, resistance decrease. So this is the external factor. Are you clear about it? Okay, let's go to the next one. Yes, let's go to our question based on parallel resistor circuit. Already addition of parallel resistor we discussed last week. Direct addition of parallel resistors and series resistors. Now we are going to include current into that. For example, we'll do it with the question because there is no theory. Okay, there is no theory. You don't have sentences. You just give a diagram, and from there only we are able to explain the concept. So let's say a simple diagram, something like this. $20 ohm, 30 ohm. There are two resistors. Let's say this is X and this is Y. It is connected to a battery of 120 volt. Now the question is, listen to this carefully, find current at Y. You can say IY. That is, the current goes like this. This is I total current. Then it moves here, that is IY. The remaining current goes up like this and that becomes IX. Can you understand here what happens is total current goes and one part of it becomes IY, the other part becomes IX. Find IY, IX and I total. How are we going to find this? There is one very important concept. Okay. They don't mention that directly in our syllabus. They want the teachers to explain about that. But sometimes school teachers also fail to explain about it. So like students don't know that there is a concept like that existing. Last week I gave you the series concept. In series, current throughout the circuit is same, voltages will be different. Here opposite of that, this is parallel, right? Because it's parallel, for parallel circuit, voltage is same, current will differ. So now with this word voltage is same, the question becomes ultra easy. It becomes mara patta easy, very simple. And also find R total. I forgot to mention that R total. Can you all do these four simple questions? Because if you find IY and IX, when you add that, you will get I total. Directly you can find it. And then you can find RT. Yes, please try this and see. After that, I will show you how to do it. If you want the addition, resistor addition, you can use, if there is possibility to use short method, you can use the short method. So that means the current gets divided. Is it? Yes, current gets divided and separates into different pathways. That is in parallel. But in series, we have only one main circuit. So the current travels, same current travels throughout all the resistors in series. In parallel, it may differ. It may be same, but majority of the time it differs. It is same if the resistance values are same. Other than that, current values will be different. You all can try this. I have given the main point. Voltage is same in parallel connection. Use that word and try to do the question. Yes, one student has got all the answers correct. Good. Rayyan correct. Fatima correct. Good. Others also just give it a try. Okay, normally, yeah. I'll make it easy for you all. Now here we have a 12-volt battery, right? Normally we consider parallel addition of resistors is hard, right? Yeah, parallel addition of resistor is harder than. So in the ohm symbol, some are writing without the lines in the end. That is possible. Ohm, if you write like this, correct, no problem. The real symbol is like this. They are not putting it. No issues with that. Yes, so what happens is, Buddha, if this battery's voltage is 120, this parallel one here also voltage is 120. It can't go beyond that. Maximum voltage here also 120. So it's very easy. If you want to find IY, now this first question you want to find IY, right? To find the IY, we have to use V equals IR at Y. At Y only, not to the whole circuit. So it will become Vy, Iy, Ry. What is Vy value? According to this concept, voltage of battery will be equal to all the parallel circuits. So battery's voltage is 120. Voltage across the Y circuit is also 120. Current at Y, we have to find it. Ry is resistance, that is given as 30, no? That is given as 30. 120 divided by 30 will give you the IY value. IY value is 4 ampere because I is current. 4 ampere current. Are you clear about this? We used V equals IR to that specific part of the circuit and got the answer. What made it easy for us? The resistant concept. We will finish by 8 because 8 o'clock I have my grade 11 paper class. We'll go until 8. Yes, next one, Ix. To find the Ix, I have to use the equation V equals IR at X. So I can convert it to Vx, Ix, Rx. Because this circuit is parallel, voltages are same, therefore voltage across X, the voltage is 120 volt. So this concept made it so easy for us. Actually, this is a real, very, very important concept. I think directly in the textbook it is not given. They are expecting the teachers to do questions like this and explain it. But because it is not there, some teachers think that it is not needed in the syllabus. They don't teach it. But go and check out the past papers. How many series and parallel current related questions are there? So here again voltage is 120, Ix is unknown, Rx is 20. That 20 value is already given, no 20 ohm. So 120 divided by 20 will give you Ix 0, 0. This will get cut. Ix is 6 ampere. Then second one also done. Third one, I total. I total is very simple here. I total is the addition of Ix and Iy. If there were 3 parallel circuits and each are A, B and C, Ia plus Ib plus Ic will give you I total. In this situation, there are 2 resistors, 2 different types of current. When you add those current, it will give the total current. So I total is equal to 4 ampere plus 6 ampere, that is I total. I can double check this. So I total is 10 ampere, right? I can double check this with V equals IR to the total circuit. Next page I will do it. Before that, we'll do this is to find I total. Then R total. How can I find R total? I'll write it at the bottom. No problem. No, hope you all can see it. Or shall I use the next page? I'll use the next page. So you all know the parallel resistors. Here the question is here 12 ohm and 30 ohm. The basic method is 1 over R total is equal to 1 over 30 plus 1 over 20. The ones who don't know this, go and watch the recording. Last week I have explained to you how to add all the parallel resistors. I have given all the short forms related to that also. This becomes 60, no? LCM is 60. Then this becomes 2 plus 3, which is 5 over 60. That is 1 over R total value is equal to 5 over 60. Therefore, R total value equals 60 over 5. Oh, 60 over 5 is 12 ohm. This is the R total value. Okay, this is a long method, no? What if we are going to use the short method? Okay, if all the resistors are same, we have different short method. But if there are two resistors, they are parallel and they are different. 20 and 30. R1, R2. What is the shortest method to do that? R1 into R2 divided by R1 plus R2. That is going to give R total. So in this situation, what is R1? 20 into R2, 30. Then below R1 plus R2, 20 plus 30 is 50. 20 into 30 is 600 divided by 50. We said this will get cut 12 ohm. So I can use the long method. Long method and get the answer. That is also correct. Can use the short method and get the answer. This short method is only applicable for two parallel non-equal resistors. If the resistors values are equal, there is another short method that is one of the easiest method. No? Are you clear about it? Okay, then earlier we found that I total is 10 ohm, 10 ampere, right? That is by adding the individual current, right? By adding the individual current, we got it as 10 ampere. Shall we double check and see? To double check that, we are going to use V equals IR at total circuit. For the total circuit, we are going to use V equals IR. So V total, I total, R total. V total is the total voltage, that is the battery's voltage, 120 equals I total into R total. Just now we found R total as 12. 120 divided by 12 will give you the I total, which is equal to 10 ampere. Now see, in this method also we double confirm that I total is 10. Earlier method, by adding the individual Ix and Iy, that also we found it is 10. So our answers are 100% correct. Just go through it. Take some screenshots. Later, please try the questions on your own. If you have any doubts, you all can write until the others take. You all can ask until the others takes screenshot. Are we gonna get only two resistors in diagrams? No. 2, 3 can come. Next question I'll give about 3 resistors. Yeah, the factor part, those writings are not available now. You can watch the recording and get a screenshot from that. If you have any doubts, you all can ask. R total again, please. To the R total, I think you were not there, no, for the last week's class. R total, whenever it is parallel, you use this method. To get R total, you have to add all the parallel resistors, but you can't directly add it. Like 20, 30, you can't add. Only if it is series, you can add. So 1 over 30 plus 1 over 20, in that method, you have to add, and you will get the 1 over R total value. Once you get the 1 over R total value, 1 over R total equals 5 over 60. How to convert it to R total? Just upside down. We call it in maths, we call it reciprocal. We make RT over 1, this side upside down, other side upside down. 60 will go up and 5 will come down. In maths, that is known as reciprocal. So R total equals 60 over 5. These are like, you can divide these numbers and you will get 12 as the answer. We have completed this theory part, current electricity theory part in all our classes, and we have started inheritance. Inheritance also halfway done. Next week, most probably, in all the institutes, we will be finishing our next week or the first week of December, we will be finishing the syllabus, grade 10. And then the other 2 weeks, we will be doing our final paper. So today is the last free paper classes for the grade 10 students. So again, we will meet you in paper classes during January as new grade 11 students. Don't worry, you stay in the group. I will give all the details related to our grade 11 paper classes. That is going to be like every week, not on and off. Every week, it's a paid class. So hope, yeah, you all don't leave the group. Again, we have a WhatsApp group. In that, I'll just update. Then if the timing is possible, you all can join to our paper classes next year also. Next year also, grade 10 free paper classes will be there on and off. Grade 11, as usual, our paid classes will be there. Yes, try this question. Let's say A resistor, B resistor, C resistor, මෙයාට දෙමු 20 ohm,
You don't talk.
15 ohm, and 30 ohm. Yeah, all our timings will be changed because next year it's going to be Mara Problematica. Next year, school timetable will be government schools. I think I told this in the theory classes. 7:30 to 2 p.m. That will be the normal timing. For Muslim schools, especially Muslim government schools, the timing will be Monday 7:30 a.m. to 2 p.m. I think you all got this, no? In school, did they inform? Tuesday, Wednesday, Thursday, 7:30 to 2:45, and Friday it will be 7:30 to I think it's 12 or 11:45. I can't remember. I'll just put 12 to. So this will be the timing. So it's very hard for us to start physical classes. Normally weekdays we have, as tuition teachers, we have physical classes starting at 3:30. No, now 3 is impossible. 3:30 is also uncomfortable for the students. So therefore, all the physical classes we are weekdays we are hoping to have the online classes, and weekend we are going to totally dedicate to physical classes. So Saturday, Sunday will be my physical classes. Master Academy Kolannava, Saturday. Sunday will be Master Academy Vellavatta. Monday, Tuesday will be the online classes. Monday, we will have grade 10 theory, grade 11 theory, grade 9 theory, and grade 11 paper. So mostly your next paper class will be happening on Tuesday night. So for now, arrange the timings like that. There is a comment, sir, I am gonna be dead after coming to school because the school is 16 kilometers far. Yeah, and even in Colombo, even if your house is closer to your school, when you come in the road, the traffic takes about half an hour. So for international school, didn't they change anything? No. International schools also they will change. Now already some international schools, their new term started. They started with a new pattern. Already some of the things are already this timing has started in some international schools. Are you clear? So therefore, most probably next year, Monday, Tuesday will be our fixed online timing. Monday night, Tuesday night. I think 5 we can start now, 5:30. After coming from school, like 2:45 or 2, then you all can take a wash and take a small you take your lunch and relax and then start by 5:30. I think for online class it won't do a big effect. But for physical classes, it's very hard. So that's why we have decided it. So Monday, grade 10, grade 11 theory. Tuesday, grade 9 theory. And the night class will be the grade 11 paper classes. So just keep it in mind. We will send you a school traffic and office traffic will combine. Yeah, yeah. Almost those two are like coming closer. Even right, it will be like the morning traffic. Yeah, here if I give the battery value, you all can start the question, no? So let's say the value of the voltage here is 6 volt. Try this question and see. A-level students also same timing. What should we find? Very good. Sorry, I didn't give the question. No. Let's say this is A, B, and C. IA, IB, IC, and I total. So I total current will go like this. Few will go this way, few will go this way, and the remaining will go this way. So if you find IA, IB, IC, and add it also, you will get I total. Yes, so you all have to find IA, IB, IC, then get I total, and finally find R total. Is 6 volt enough? No, it does. So it's not a issue. Like, the value of the voltage is not an issue. Only thing is, if you use low battery, current will be less. That's all. The brightness of the bulb will be less if they are using bulbs. Yeah, decimal can be there. Point values can be there. But all the point value which they give will be like, easily obtainable. You can cut easily and get it. Those kind of questions only they will give. Especially for science, not for maths. So 50. What about this? Okay, let's do the calculation part. Yeah, many have given the answer correct. Good. Fatima, Hari, May. Yes, I think too so. Okay, Balana. Atif, correct. The last one, no? Total resistance, can it be a decimal recurring? Maybe, yeah, that one, okay. I thought the total current. Sorry. So let's find IA. IA. Here the most important concept you have to remember is, if the voltage of the battery is 6, all the parallel voltages are 6, 6, 6. So this is the most important concept I wanted to tell you all in parallel. In series, last week we discussed current throughout the circuit is same, current won't change, voltage will change. Here, voltage won't change. In parallel, voltage won't change, current will change. Current will change. Hari, IA equals, to find IA, what should we do? We should use V equals IR. We'll find to find IA, I have to use V equals IR at A. Then to find IB, I have to use V equals IR at B. To find IC, I have to use V equals IR at C. So I can put VA, IA, RA, VB, IB, RB, VC, IC, RC. So VA value, whether it is VA, whether it is VB, whether it is VC, VX, VI, VZ, no problem. Here it won't change. Voltage is same. 6 volt, 6 volt, 6 volt because it is parallel. IA and RA. What is the A value? 20, 15 and 30. RA value 20, RB value 15, RC value 30. Then 60 over 20 is equal to IA. 60 over 15 is equal to IB. 6 over 15, 6 over 30 equals IC. Now here don't think decimal is going to be really hard and you have to divide 6 by 20. There are many methods. I'll just show you. If I were you, what will I do? I will try to make the denominator 10 or multiples of 10. Then it is easy for me. So 6 over 20, I can write it as 3 over 10, right? I can make it 3 over 10. Then the answer will be 0.3 because anything divided by 10 will get 1 decimal point. Anything divided by 100 will get 2 decimal points. So here directly I got the answer 0.3. If it is 6 over 15, what will I do? I can divide up and down by, first I can divide it by 3. Then I will get 2 and 5. Now I'll multiply up and down by 2. Then it will become 4 over 10. Then for me it's easy. When I see 4 over 10, I can directly go for the answer 0.4. Your method might be different. You might have a better easy method. No problem. Maths, different students can have different methods. Last one. If I were you, what will I do? 6 over 30. I can divide up and down by 3 so that I can get a easy decimal answer. Easy denominator. Then I can convert to decimal. So I will divide this by 3. This will become 2 over 10, no? Which is equal to 0.2. Now I can go until 1 over 5, but don't need, no? Because if I can get the answer easily here as 0.2 ampere, then I can do it. So these calculation methods are unique to each person. I might find this easy. You might find it hard. For you, long division method might be easy. No problem. Follow that method. What we want is to get the correct answer. Whatever method you are using, no problem. So then I have found IA, IB, IC. So if I want to find the I total, IA plus IB plus IC. So 0.3 plus 0.4 plus 0.2, I will get 0.9 ampere as the total current. So until this, no problem, no recurring or anything. I think the last one, IR, is only recurring, no problem. There are resistance, you can keep it as a fraction, but whenever you are coming to like current, better to keep it as a decimal point. So we'll add the resistance R total. We have 20, 15, 30, no? 20, 15, 30. 20, 15 and 30. Those are the values, no? You can use 1 over R total. Here you don't have short methods, no? If all are same, you have a short method. If there are 2 and if they are different, then you have a short method. Other than that, no short method. 1 over R total equals 1 over 20 plus 1 over 15 plus 1 over 30. Now for all this, we have to get a common one. Least common multiple. We are calling it LCM. LCM of 20, 15, 30. I think we can go for 60, no? Here 3, here 4, and here 2. So 1 over R total equals 9 over 60 Then how to get the R total answer? Upside down. We call it reciprocal. R total equals 60 over 9 ohm. We will further slightly, Munada, simplify. You can cut with 3 and 3. Here it will be 20. Here it will be 3. For R total, you can keep it as 20 over 3 ohm. Or else you can divide it and get 6, 12, 18, 6.66 ohm. But whenever you try to do a calculation, keep it like this and do, because in our syllabus they will give calculation values which are getting cut very easily. For example, if I want to find the I total directly, how, where someone has asked, how 3, 4 and 2? Bad, I tried to find R total first and got confused. My bad, sir. Wait. Important messages, have I skipped it? LCM, Buddha, that is known as LCM method. Now, if you make the denominator to one value, for example, I will ask the question, how did 20 become 60? I multiplied by 3. Then up this one also should be multiplied by 3. That's how I got the 3. 15, how did it become 60? I multiplied it by 4. Then this upper fellow, we call it the numerator, that also should be multiplied by 4. Whatever you do to the down house, you have to do to the upper house also. You can a denominator and numerator. So how did this 30 become 60? Multiplied by 2. So 1 into 2, that's how we got the number. That is the basic maths part. If you are not that much aware of that, please go and thorough, make it thorough, because you will be needing it in your O levels a lot. Okay, now let's say I want to put V equals IR to the whole circuit total. Then V total equals I total, R total. In this situation, don't use the decimal, use the fraction, then it will be easy for you all. V total kiya the Buddha? Voltage of this 6 volt battery, no? 6 or 12 volt there? Forgot the question also. 6 volt equals I total. We'll try to find it. Already we found it 0.9. We are going to double confirm. Into R total. In this R total, don't use this one. Better use this or the, before simplifying you got that answer. So R total is 20 over 3, no? Now to find I total, we have to send all the things to the other side. 6 division 3 when going to the other side will become multiplication. This will become multiplication will become division, that is IT. 6 into 3 is 6, 12, 18 over 20, which is equal to 9 over 10, that is equal to 0.9. So earlier by adding all the voltages we got 0.9 ampere. No? Here we are double confirming it is 0.9 ampere. Are you clear about that? So electricity superb. This side you can start from one side and end in the other side, or start from the end and go back to the front side. That kind of clear calculations. Without what all we can't, we just use the method you said for O levels. So without doing all that, can't we just use the method you said? Yeah, any method you can use, but all depends on the question. You can, if it's a structured essay or essay, whatever question they are asking, step by step you have to show IA, IB, IC. Now the short method we got the I total, but here we can't find the IA, IB, IC individually. No. So if they go for question IA, you have to use this IA method and get V equals IR at A, and you have to get the IA, then IB, then IC. Then I total, if they give, you can add and get it, or you can do this short method which I gave you. Not short method, it's a normal method. applying V equal IC, V equals IR for the whole circuit. So I think from these two paper classes, watch the recording of the previous one also. I will upload both in the groups. Once the YouTube video is ready, I will upload. From this, what I'm telling you all is parallel questions might come, series questions might come. There are additions, resistor additions also differ. Series normally, resistor additions is easy. R total equals R1 plus R2 plus R3. That is the easiest resistor addition. Parallel, if it comes 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. This is the official method. Unofficially, I gave you two method shortcuts, but those are limited to certain conditions. But this one can be used for any question. There is no limitation. Okay, I think it's 8:05. We'll have to stop it. Yeah, give me 1 minute. Then, if you look at the circuits, parallel circuit with a battery, parallel one, what you have to remember is voltage is same. Each flow, upper flow, upper flow, upper flow, voltage is same. Current will be different. The questions which we did today explains that in a circuit one. In a series is for parallel. In series circuits, what is same? Current throughout the whole circuit is same, but voltage at each place will be different. If you are 100% clear about this, my two paper class for the last two paper class is successful. And also, without any fear, without any issue, use the V equals IR. If you want to use it for total circuit, just put at total, just mention it and use it. Don't get scared. If you want to use it for A part, the place where the A resistor is there, VA equals IA into RA, put like that and use it. If it is X, Vx equals Ix into Rx, like that without any fear, use this V equals IR equation properly in the needed situation and get the answer. Because this is the only savior, V equals IR is the only savior for grade 10. Because all the other physics equations for electricity, we will learn the other equations for electricity in grade 11. For now, we have only this one. Use this properly and get the answer. So all the best. So who finds the equations for parallel? Some person only, I don't know. But short method, some I have got it. With experience, I have got the short method. Some other teachers also have identified the short methods. They use it. Okay, so all the best, all the very best for your exams and hope to meet you all again. In our theory classes, we will be doing papers because last two will be papers. Final third term paper. Again, our official paper classes, you all will start as the new grade 11 paper classes in your new grade 11. January first week itself, it will start. Make sure from first you are joining the theory and the paper classes so that you improve your results. So now itself, start preparing for grade 11. What is the preparation you have to do for grade 11? Don't read any grade 11 notes. Okay, you don't need to read grade 11 notes. Preparation for grade 11 is revising your grade 10 properly. That is the best preparation you can do for your grade 11. Because once you start grade 11, from first I will explain grade 11 from A to Z. But if your grade 10 is weak, again you will have to come to grade 10 classes. Okay, so what I am telling is use these holidays, use this exam period to, yes, what is the question? So, use this exam period to recover all the forgotten parts. So we can get marks for the part as well, VA, VB, VC, finding individually. Yeah, if it is series, you have to do the calculation and find VA, VB, VC. Then for that you will get the marks. But in parallel, no use of finding voltage, no. Because already voltage is, when you see itself, you know what is the voltages. So in parallel, finding current is different, no? So finding current will be the hardest question. The marks will be awarded for that. In series, voltage will be different. So finding voltage will be the main question there. So do more questions, attend more paper classes. If possible, watch all the free paper classes which I have done. It's all there in YouTube. Okay. Watch it before your exams. It will be really helpful. Okay, then Assalamu alaikum. Good day. Sorry, good night. And all the very best to your exams. Yes, we'll have to start grade 11 now.